Hi guys, today is April 27th and we're going to learn how to graph the 6 trig functions today, okay? So the very get-go, okay, I want to show you like what does the graph of y equals sine x look like, okay? And if you look on our x-axis, okay, um, these numbers right here, they look like radians, right? And that's because they are, okay? Because we're going to graph y equals sine of x, and x is the angle of rotation, and so I want to do this in radians, okay? So that's why the x-axis looks kind of strange, right? It has a lot of pi's involved in it, okay? All right, so I'm going to go to the graphing calculator right now, and we're just going to look at the graph of y equals sine x and y equals cosine x and y equals tan x, and then we're going to come back and do it by hand and try to show you why it looks the way it does, okay? All right, so I'm going to go to the graphing calculator right now. So for this, we want to make sure we're in radian mode. So you want to look up here at the top of your screen and make sure that you're in radian mode right there, okay? And so we're going to go to y equals, okay? And we're going to type in sine of x. And this is going to graph sine x, okay? And then let's go to our window. I'm going to set up the window so it looks like our grid today, okay? So our x min, I'm going to put at -3 pi. So -3 and pi. And then x max was at 3 pi. If you look at your notes, you see that. And then x scale. 2 lines is pi over 2. So that means right in the middle is half of pi over 2, which would be pi over 4. So I'm going to put in pi over 4. You know, it doesn't let me do the fraction bar. I forgot on this. So pi, whoops. I pressed the wrong one. Dang it. Let me get on top of the h and delete that. Okay, there we go. And then divide by 4. So that's pi over 4. Y min, let's go. I made the grid on our notes all the way down to -2. Okay, and our y max is 2. And then our y scale is by 0.5. And so when we do this by hand, our graph should look fairly similar to this one, okay? So we graph, and there it is. It looks like this, okay? So why? Why? Now, right here, this is pi over 2, right? And so it's kind of this wave, right? And if usually Mr. Jet and I do this right around the same time, and I think you guys were just starting to talk about waves in physics, okay? So right here, this is a wave, right? And it starts to repeat every so often. So from here to here, it starts to repeat again, right? And there's a height to these, how high they go up. Now, this is 0.5, so this is 1. So why does this only go up to 1? Why doesn't it get any bigger than that, okay? And so some questions we might have is like, how long does it take to repeat? How high does it go? How low does it go, okay? And notice, if we're scaling the y-axis by 0.5, that would make this -1 right here, right? Right here, this would be -1 right there, okay? All right, so let's take a look and see what does cosine look like, okay? So I'm going to go y equals, and I'm going to change to cosine. And cosine x looks like this, and press the graph of that. Slightly different, kind of the same shape, but slightly different, right? Okay, it's at a different location than sine x, okay? And why does that happen, all right? And we'll talk about that today, okay? And then finally, let's go to tan x, okay? And so let's go to y equals, and let's type tan x. Okay, and graph that. And this one looks different than those, right? It looks like this. Now, there's going to be something that I want to point out to you. Okay, right here, right where it's crossing the x-axis, this doesn't. There's going to be vertical asymptotes here. Okay, I'm going to explain that. Okay, but one thing I want to point out is it doesn't flatten out here. You know how like a cubic flattens out? Tan does not flatten out. It just passes through. Okay, you see that? You see how it doesn't curve and go horizontal and curve back up? All right, this is just kind of a straight, kind of curvy line. All right, it doesn't go horizontal where it crosses the x-axis. Okay, all right. So when we draw them, we want to make sure we're not doing that. Okay, because that wouldn't be right. Okay, and then one more I want to do. Is let's do one of the reciprocal ones that we learned. Okay. So we're going to put in the fraction bar, and then let's do 1 over sine x. Okay, so this is the definition of what cosecant is, right? Because cosecant x is 1 over sine x. So we graph this one, and it looks different, right? There's nothing in here, like there's an alley in here, right? Right? There where nothing is happening. And that's between -1 and 1. Nothing is happening, right? But this one's also going to have some vertical asymptotes, okay? All right, and we'll try to describe that and explain why that's happening today, okay? All right, so let's go back to our graphing, our notes, and I'll show you how to graph these by hand, okay? Okay, so on our notes, okay, there's a point on this circle, okay, and we're going to call it x comma y, and then that means that we would have a radius from the center here, right? A radius, okay, and this point's going around, okay, and okay, I want to say something. This y right here is different than this y, and this x over on this circle diagram is different than this x. This x is the angle of rotation, okay? This is the x and y coordinate, and we, along with the angle of rotation, because remember this is angle theta, right? Right here that we rotate, okay? So they're different, all right? We're not going to talk about x and y over here. We're going to talk about x and y and r over here, okay? All right, so right now we know this is angle 0, and as we go around, then there's a point right here. Okay, and remember, if there's a point right here, we use the simplest radius there is, and we'd use radius of 1, okay? And so as we go around, this would be angle 0 rotation. Up here, if we came to right here, this angle right here would be pi over 2, okay? So we're going to do like quarter turns, okay? Then if we keep going this way, this would be 2 pi over 2, or pi. And so if that's 2 pi over 2, then right here, this point right here would have to be, the angle of rotation would have to be 3 pi over 2. Okay, and this would be 4 pi over 2, or 2 pi. If we kept going, this would be 5 pi over 2, 6 pi over 2, or 3 pi, 7 pi over 2, 8 pi over 2. We can keep doing that. And we can keep doing that in the negative direction too, right? If this is angle 0, then this would be angle negative pi over 2, negative 2 pi over 2, which would be negative pi, negative 3 pi over 2, negative 4 pi over 2, or negative 2 pi, okay? All right, now what is the definition of sine? Well, sine is your y coordinate on the circle. The sine is the y coordinate over your radius, right? Okay, so we're gonna pick some really nice angles to find this really quickly, okay? And so we're gonna pick these angles, 0, pi over 2, pi, and 3 pi over 2, and then 2 pi, okay? That's what we're going to do with this, all right? So what is the coordinates? We're going to use radius of 1. What are the coordinates of this? If the radius is 1, then the coordinates of this point right here would be 1 comma 0, okay? If we kept rotating to pi over 2, the coordinates of this point would be 0 comma 1, all right? And if we came over here, the coordinates of this point right here would be negative 1 comma 0. Keep going, and this would point right here at 3 pi over 2 would have coordinates, an x coordinate of 0 and a y coordinate of negative 1, okay? And then we keep going, and we're back to the same point of 1, 0, okay? So that's how we're going to do this, okay? If we put in angle 0, so this is a point that we're going to graph. If we put in angle 0 radians, what do we get out? Well, for sine, we get out the y, which is 0, over our radius, which is 1. So this would be 0 over 1, which is 0. Okay, so that's the first point we're going to graph. It's 0, 0. Okay, so sine starts right here at the origin at 0, 0. The next angle we're going to use, or next point we're going to graph, is pi over 2. That's what we're going to put in. Well, when we rotate up here to pi over 2, our y is 1 now, and our r is still 1, right? So that'd be 1 over 1, which is 1. If we keep rotating, now we're going to put in angle pi, okay? And that would put me right here at this coordinate, and my y coordinate would be 0, and my r is 1. So that'd be 0 over 1, or 0, okay? So I meant to do this just a minute ago, and I forgot to do it. Pi over 2, we're up here at 1, okay? And that's as high as it's going to go, okay? That's as high as our y coordinate can ever get is positive 1 because it's going to be the same as whatever that radius is, okay? And the ratio of whatever the y coordinate to the radius is will always be 1, regardless of what the radius is. Because if the radius was 2, this point up here would be 0, 2, and then we'd have a ratio of 2 over 2, which is still 1, right? Okay? So over here, angle pi, it's back to 0. Okay, so now we're over here. If we keep going, okay, now we're at angle 3 pi over 2, right? And if we're at angle 3 pi over 2, what's the y? And let me write 3 pi over 2 for my x. So we're putting in 3 pi over 2 in here, and what are we getting out? We're getting out the ratio of this y coordinate to the radius. So that'd be negative 1 over the radius, which is 1. So that'd be negative 1 over 1, which is negative 1. Okay, and so at 3 pi over 2, I'm going to come down to negative 1. Okay, and then I'm going to keep going to 2 pi. Okay, and at 2 pi, all right, that would be the ratio of y to r still, right? So let me write 2 pi. And that would be my y coordinate, which is 0, over my radius, which is 1. So that'd be 0 over 1, which is 0. So that'd be 2 pi comma 0. And this is, I call this the well, it's not just me. People call this the 5-point method. So we graph 5 points on this, okay? So 2 pi comma 0. Okay, now what if we kept rotating? Okay, if we kept going around in a positive direction, okay, this was 3 pi over 2, so this is 4 pi over 2, then this would be 5 pi over 2, and at 5 pi over 2, we're back here, right? And the whole thing just starts to repeat, right? So at 5 pi over 2, that'd be the same as putting pi over 2. So we can just use this pattern, okay, to help us figure this out, okay? Now, from the graphing calculator, you wouldn't know this unless you plotted more points, but this is a nice smooth curve, right? And this is the high point and this is the low point. So really all I want to see from you guys is to graph and just go up and kind of flatten out right here and then come down through this point right here and then turn and bottom out right here at 3 pi over 2 and then come back up. Okay, and then I want you to I want you to fill the whole grids up when I give you grids. Okay, I want you to go from left all the way across to fill them all up. Okay, so at 2 pi, okay, now it's going to start to repeat. So it was down here at negative 1, now it's at 0. Right here at 5 pi over 2, it's going to be back up to 1. And then at 3 pi, it's going to be over here, which means we just come back down. And so it looks something like this, right? And that's the graph of sine x, okay? Now, let's graph over here on the negative side. Well, it still repeats. Up here, it's at 1, right? Then it's at 0. Well, what happened if I rotate in the negative direction? Well, negative pi over 2. That would put me right here at 0 comma negative 1. Well, what's the y coordinate? Negative 1. What's the radius? 1. So that'd be negative 1 over 1, which is negative 1. So at negative pi over 2, we're at negative 1, right? But did you really need to do all that? No, because it's just going to alternate from being high to low after you hit a 0 right here, okay? All right, so then what happens over here at pi? Well, it's going to be back at 0. What's going to happen at negative 3 pi over 2? That's going to put me at 1. How about at negative 2 pi? It's going to put me at 0, right? It's just going to start, it's just repeatedly going over and doing the same thing over and over and over again. So then over here, it's going to be at negative 1. And then at negative 3 pi, it's going to be at 0. Okay. Now, if you look at this, it looks like a sawtooth, right? Jiggy jag, right? But we know because we graphed it on the graphing calculator, this is a nice smooth curve. Okay. So I'm going to, it's horizontal right here, and it's horizontal right here, and it's horizontal right here. So I want to see that, okay, that it goes horizontal. So we're going to turn and go up. Here, we're going to turn and go down through the 0. I like to do this in pieces, okay? And then like that, and then like this. And that's the graph of sine x, okay, guys? All right? So it's really just y over r, right? And our input is the angle of rotation, and the output is the ratio of the y coordinate to the radius for this, okay? And we're going to use the same diagram for all of these, okay? All right, to help us figure things out, okay? Now, one thing I want to point out, in here, between 0 and here. That's 0 to pi over 2. This is from here to here, quadrant 1. So this is going to help us with some stuff, okay, in a little bit. That's quadrant 1. And quadrant 1, what do we know about the x and the y? They're positive, okay? All right. And then if we go over here from pi over 2 to pi right in here, this is quadrant 2. So from angle pi over 2 to angle pi, this is quadrant 2. And quadrant 2, I know my x's are negative and my y's are positive, okay? All right, so depending on the ratio, this could be a positive ratio or a negative ratio over here. But in the first quadrant, they're always going to be positive because x, y are both positive in this quadrant, okay? And then if we go to from pi to 3 pi over 2, that's describing the third quadrant. So from here to here, this is quadrant 3. The angle of rotation would put me down in this quadrant down here. Well, what do I know about down here? Well, I know my x is negative and my y is negative. Now, still, my ratio, if I use x's and y's and r's, could be positive, could be negative, okay? Depending on what combination I'm looking at, okay? And then from 3 pi over 2 to 2 pi, all right, I know that this is quadrant 4. Because that's how we label the quadrants. This one's 1, this one's 2, this one's 3, and this one's 4. Okay, and what do I know about in this quadrant? In this quadrant, my x's are positive, my y's are negative, okay? All right, so depending on what trig function you're using, you could get a positive ratio or a negative ratio out of that, okay? But when we graph sine, this is important, when we graph sine, the x here is the angle of rotation, and the y here is the ratio, is the specific ratio for sine, okay? This is x and y for the graph. This is x and y for the rotation, okay? And the point that we're rotating around the circle, okay? All right, so now let's do cosine x, okay? It's gonna look very similar, but slightly different too, okay? So now we're gonna do y equals cosine of x, okay? And we're gonna use the same type of diagram, okay, to help us figure this out. So right here is angle 0, okay? And I'm gonna use, again, I'm gonna use a radius of 1 to figure this out. It's just the easiest radius to use, okay? So if this is radius 1, then this point right here would have an x coordinate of 1 and a y coordinate of 0. Right here, the x coordinate would be 0, but the y coordinate would be 1. Here, the x coordinate would be negative 1, and the y coordinate would be 0. And then the point right here, this x coordinate would be 0, and the y coordinate would be negative 1. And then we come back and we start all over again, right? Okay, so with that said, okay, I know that at angle 0, okay, so I'm going to put 0 in, the point 0, angle 0, cosine is x over r. Okay, so my x is 1 and my r is 1, so that's going to be 1 over 1, which is 1. So cosine doesn't start at 0, 0 like sine does. It actually starts up here at 1 because the ratio of x to r is 1. Okay, keep going to angle pi over 2. At angle pi over 2, and now let's write the point, pi over 2. Okay, so at angle pi over 2, I know that my x is 0, okay, and my r is 1, so that'd be 0 over 1, which is 0. So at angle pi over 2, it's 0 right there, okay? Keep rotating around to pi. So if I put in pi, that's the ratio of x to r. So my x is negative 1, my r is 1, so that'd be negative 1 over 1, which is negative 1. So at angle pi, I know my output for this function is negative 1. Keep going to 3 pi over 2. Okay, and 3 pi over 2 would put me right here. And I know my x is 0, and I know my r is 1. So 0 over 1 would be 0. So this would be 0. So 3 pi over 2, I'm back to 0. And then at 2 pi, I'm back to where I started, right? Okay, so what's my x? It's 1. What's my r? 1, right? So if I put 2 pi in, I'm going to get out 1 over 1, which is 1. Okay, so at 2 pi, it's 1. Okay, now it looks like a V, right? It's not though, okay, because we know there's curvature to it. Okay, so it's horizontal right here, it's horizontal right here, and it's horizontal right here, and so I know that this is going to curve something like this. It doesn't have to be perfect, but it needs to be flat here, and going through this point. Okay, it needs to be flat here, and going through this point. Okay, so it's going to look something like this. Okay, now you can use the pattern of the graph to just keep repeating, right? So we're at -1, then we're at 0, then we're at 1. So this next one right here, we're going to be at 0. And we don't even have to use this really, right? Once we get these 5 points, you really don't have to use this anymore, okay? And then the next one would be down at -1, right? At 3 pi. And so this is going to be horizontal right here. So it's going to turn and go right here and then back up like this, okay? And you just kind of show that it's going to come back up, okay? So up here it's at 1, so the next angle at negative pi over 2 would have to be 0, and the next angle at negative pi would have to be at -1, okay? And then the next angle I'd have to be coming back up, and then to 1, and then to 0, and then to -1, okay? And it does look like if I just connected these, it'd be sawtoothish, right? But I know it's flattening out right here, and I know it's flattening out right here just because that's why I showed you the graph on the graphing calculator. So it's going to do something like this, and then something like this. And if your graph looks like that, I'm a happy, happy teacher, okay? Once again, okay, this right here, this from angle 0 to angle pi over 2 is this first quadrant in here, right? That's quadrant 1, okay? From pi over 2 to pi, that's quadrant 2. Okay, so why is it, okay, so my ratio is positive up here, right? Because my ratio is x to r, right? And this first quadrant, my x is positive and my r is always positive, right? So that's why this graph from 0 to pi over 2 is above and it's positive, okay? It's above the x-axis, okay? Why is it from pi over 2 to pi that my graph is going below? Why is it below over here? Well, this is quadrant 2, right? This describes quadrant 2. Well, what do I know about my x's in quadrant 2? All of my x's are negative. My r's are positive, so when I go to do the ratio, it's going to give me a negative value. That's why everything in here is going to be negative. It's going to be below the x-axis, okay? From pi to 3 pi over 2, that'd be this one right here. That's quadrant 3. Okay, and quadrant 3, I know that my x's are negative, right? And since my x's are negative, when I go to do my ratio has to be negative. That's why this part of the graph is below. Okay, from 3 pi over 2 to 2 pi, that's quadrant 4. That's this one, right? Okay, so in quadrant 4, I know that my x's are positive. So when I go to do the ratio of x over r, my ratio is going to be positive. That's why the graph from 3 pi over 2 to 2 pi is positive, right? It's above the x-axis because I know all my ratios are going to have to be positive, okay? You can do the same thing with sine, okay? This is the first quadrant, and I know in the first quadrant my y's are positive, right? That's why this part of the graph is above. Okay, and from pi over 2 to pi, that's quadrant 2, right? What do I know about the y values in quadrant 2? Well, they're positive. That's why this part of the graph is above. Well, why is this part of the graph below? Because from angle pi to angle 2 pi, right? What do I know about my y's in these two quadrants? My y's are negative. That would make the ratio be negative, and that's why this graph is below the x-axis, because all of my ratios between pi and 2 pi have to be negative, okay? Right? That's going to help us out with the next problem that we're going to do. Okay. All right. So we'll finish there. Okay. And then we'll go and turn the page and we'll do the next one. All right. For the next graph, what I want to do is I want to graph y equals tangent of x. Okay. And it's going to be, I extended the y-axis a little bit higher than the last one. Okay. Because we're going to need that. All right. But right here, okay, this would be angle 0, and I'm still going to use r equals 1. Okay. On all of these, I'm going to use a radius of 1. So right here, that would make this coordinate right here 1 comma 0. Okay. Here at angle pi over 2, okay, that would make this coordinate, okay, the x coordinate would be 0 and the y coordinate would be 1. Over here at angle pi, okay, that would put the x coordinate at -1 and the y coordinate of 0. At 3 pi over 2 right here, that would make the x coordinate of 0 and the y coordinate of -1. And I'm back to 2 pi, and back to this point right here, right? Okay, so what happens on this? What if I start with angle 0? Okay, now remember, okay, we have to recall this, that the tan ratio is the y coordinate over the x coordinate, okay? So right here, if I do angle 0, my y coordinate is 0 and my x coordinate is 1. So my ratio would be 0 over 1 or 0. So for tangent, angle 0 will give me a ratio of 0. Right there, right? Okay. Now, what if I go to the next one, right? The next point, right? So the next angle, if I go in the counterclockwise direction, right, with a positive angle of rotation, that would put me right here at pi over 2. And at pi over 2, okay, right here at pi over 2, I'm going to do the tan ratio. Well, it's y over x, right? So it'd be this y over this x, so it'd be 1 over 0, right? 1 over 0. There's a problem with this. What's 1 divided by 0? It's undefined, right? So this is pi over 2, comma, and it's undefined. All right. Well, what does that mean? Okay, now remember back when we did graph rational functions, when we got a 0 in only the denominator, that created a vertical asymptote. So guess what we have on this? We have a vertical asymptote. Okay, so I'm going to grab my ruler and I'm going to graph the vertical asymptote. Okay, so I got my ruler and I'm going to graph with my ruler the vertical asymptote. Now, back to when we learned about graphing rational functions, right? What happens when you get close to these vertical asymptotes? They're either going to shoot up to infinity or they're going to shoot down to negative infinity, right? They're going to go really fast, go up, okay? Or really fast and go down, okay? We'll talk about which one it is in just a little bit, okay? All right. All right, so we did angle pi over 2, right? That was right here. Keep going around the circle. Now we're going to be right here, and that'd be angle pi. Okay, at angle pi, the ratio of y to x would be 0 over -1, and that would just be 0. Okay, so at angle pi, I can plot a point right there. Okay, keep rotating, 3 pi over 2. Okay, 3 pi over 2 put me right here. And if I'm right here at this rotation, my ratio of y to x would be -1 over 0, right? But we can't write it as -1 over 0 because -1 over 0 is really undefined. So guess what? We have another vertical asymptote. Okay, so we're going to draw on the next vertical asymptote. Okay, we're at 3 pi over 2. Now we're going to rotate to 2 pi, right? So 2 pi would put me at this one, right? And the ratio of y to x would be 0 over 1, which is just 0. So at angle 2 pi, we're going to plot the point 0, okay? Now, where is the graph below, and where's the graph above the x-axis, okay? So that's determined if it's above the x-axis or below. Remember we talked about it? It's dependent upon the quadrant, right? So 0 to pi over 2 right here, right? That's quadrant 1. Pi over 2 to pi, that's quadrant 2, right? Pi to 3 pi over 2, this describes, these x's describe quadrant 3. And 3 pi over 2 to 2 pi, that describes quadrant 4. Okay, so what has to happen here? Okay, so remember, from this point right here that we know is on the graph, we have to approach this vertical asymptote. Well, our choices are to go turn and go up or turn and go down, right? Well, what do we know about quadrant 1? Quadrant 1 is this. And what do we know about the ratio of y to x in this quadrant? Well, y and x's are both positive. So since they're both positive, my ratio will always be positive. So that means from this point to the vertical asymptote, my graph must be above the x-axis because my ratios are all going to be positive. Okay, remember, this doesn't flatten out here, okay? So right here, it's just going to come and turn and bend and go up along this vertical asymptote, okay? Now, let's move on, okay? So how about pi over 2 to pi? Pi over 2 to pi. What do I know about this quadrant, right? This is quadrant 2. So in quadrant 2, I know my x's are negative and my y is positive. So I know my ratio is going to have to come out to be negative. So my graph from here to this point right here has to be below the x-axis. And here's a vertical asymptote. So what has to happen is it has to just come and go through, okay? So it's going to look something like this. The entire graph has to be below, and it has to have the asymptotic behavior right here. So we're going to come up and go through right there, okay? Now, what's happening between pi and 3 pi over 2, right? Pi and 3 pi over 2. Well, in this quadrant, both my x and my y are both negative. So when I go to do the ratio, that's going to come out to be positive. So the graph of tangent in between pi and 3 pi over 2 is going to have to be positive, which means it still has to have the asymptotic behavior on this left-hand side. So it's got to come and turn and go up, and it looks something like this. And that's why we were getting those shapes that we were getting when we graphed tan on the graphing calculator, okay? Okay, so then what happens from 3 pi over 2 to 2 pi? That's over here, right? 3 pi over 2 to 2 pi, okay? My ratio of y to x, what do I know about the x and the y? Well, the x is positive, but now the y is negative, right? Which makes my ratio negative. So from here, from the vertical asymptote to this point, my graph has to be below the x-axis here, right? Well, it has to have this asymptotic behavior, so it has to come up along this and right here like that. And remember, it's not horizontal here. That's important. It's not horizontal. Okay, it's not like the cubic function, okay? Now, could you tell me where the rest of the vertical asymptotes are? Hopefully you can, right? They're at every pi over 2, okay? For the basic function, they're at every pi over 2. They're at pi over 2. They're at 3 pi over 2. We're going to have one at 5 pi over 2. That's what's beautiful about these things is they repeat, okay? All right, so I'm going to continue drawing the rest of my vertical asymptotes and the rest of this graph because we haven't actually finished graphing it, okay? So I'm going to draw that vertical asymptote right there. We don't need to use the analysis anymore, okay? Though, I don't think, okay? I mean, you could, but you don't have to, I don't think. So right here, negative pi over 2, we're going to have a vertical asymptote. At negative 3 pi over 2, we have another vertical asymptote. At negative 5 pi over 2, we have another vertical asymptote. So it looks something like this. So, and then for tangent, as I go around, every time I land here or here, right, I'm going to get a ratio of either 1, or I'm going to get a ratio of 0, right, because my y's are 0, okay? So 3 pi, it's going to be 0. At negative pi, it's going to be 0. Negative 2 pi, it's going to be 0. And negative 3 pi, it's going to be 0. Okay, now you can tell by the behavior, okay, from this side, the right side's always going up and the left side of this point's always going down. You can use this one to help you out, okay? So the left side of this point goes down, the right side of this point goes up. So right here, the right side would have to go up. So let's just draw it. And I'm going to have you guys practice this a lot, okay? So here's my point. The left side is always going to go down. And it has that asymptotic behavior right here. This side has to come up along the vertical asymptote and then turn to that point. Remember, it's not horizontal here, okay? So right here, this point, the left side has to be below and the right side has to be up, above. So these all just repeat. Because eventually you get back in the same quadrant, right? The angle of rotation would take you back into the same quadrant. That's why this repeats. All of these repeat, okay? And it looks something like that. And then this one would just be a half of them. Half of them. It's like a half a lump, all right? So right here, and would look like that, okay? And this would extend a little bit and put an arrow right there, okay? And that's what the graph of y equals tan x looks like and why it looks like that, okay? All right? Okay, let's go to the next one. And we're gonna do all 6, all right? So we're gonna do y equals cotangent of x, okay? So let's do that one. So this one's gonna be y equals cotangent of x. Whoops. Forgot the C. All right, so y equals cotangent of x. Okay, once again, this angle right here is angle 0, right? And we're going to use radius of 1. And so right here, if the radius is 1, the x coordinate would be 1, the y coordinate would be 0. Right here, the x coordinate would be 0, and the y coordinate would be 1. And right here, that's this. And the reason is because this distance right here is, again, it's the same as the radius, right? Okay, so the radius, if the radius is 1, I'm going to the left, so that would be -1 comma 0 for the x coordinate and the y coordinate. And then this distance right here would have to be the same as the radius, okay, but it's a y right now, and the x is 0, and the y would be -1, okay? And remember, okay, tan, and this is the way I remember it. Okay, I remember sine, cosine, and tangent, and I remember tan, okay, tan is y over x, and I know cotangent is the reciprocal of tangent. So if tangent is y over x, cotangent must be x over y, okay? So if I start at angle 0, okay, at angle 0, okay, tangent's y over x, so this one's x over y, so this one's going to be 1 over 0, right? 1 over 0. Well, what do you know about 1 over 0? It's undefined. So this would be 0, comma, undefined, which means at angle 0, we're going to have a vertical asymptote, okay? So I'm going to graph a vertical asymptote right here at angle 0. For cotangent, we're going to have the vertical asymptote right here. Okay, rotate to pi over 2. Again, tangent is y over x, so this one's going to be x over y, so that'd be 0 over 1, which is 0. Okay, so at pi over 2, I know my output is going to be 0 right there. Okay, all right, keep going to pi. So at angle pi, okay, tangent is y over x, so this one's x over y, so this one would be -1 over 0. And -1 over 0 is undefined. So at angle pi, we have it's undefined, which means we have another vertical asymptote. Okay, and then let's keep going. So we're at angle pi. Let's go to angle 3 pi over 2, which would put you down here. So 3 pi over 2. And tangent is y over x. So this one's going to be x over y. So 0 over -1, which would be 0. So 3 pi over 2, we're back to 0. And then we're going to come back up to 2 pi. And 2 pi puts us back where we started, right? And where we started was tangent is y over x, right? So this is going to be x over y. So 1 over 0, right? Okay, so at 2 pi, at angle 2 pi, we're going to get out for the ratio of 1 over 0, which is undefined. So at 2 pi, we have another vertical asymptote, right? Okay, so we'll draw that vertical asymptote in. So I would bet you can draw in the rest of the vertical asymptotes, right? Where are they going to happen? Well, they're always going to happen at your pi and pi and 0, right? So we're going to have another one at 3 pi. We're going to have another one over here at negative pi. That's just been going this way, right? Anytime we land here or here, we're going to have a vertical asymptote. So then at negative 2 pi, we have another one because that lands us on the x-axis. So basically, anytime we land on the x-axis, right? And then at negative 3 pi. And then we're going to have zeros every time we land on the y-axis, right? And we're going to land on the y-axis at pi over 2 and 3 pi over 2, all the odd pi over 2s, right? So 5 pi over 2 right here. At negative pi over 2, we're going to have a 0. And negative 3 pi over 2, we're going to have a 0. And negative 5 pi over 2, we're going to have a 0. And there's more, right? There's more. Okay. Okay, so how does this look, right? Okay, does it take on the same shape as tangent, the one above, right? And it doesn't. Okay, well, I shouldn't say that. The shape is the same, okay? But it's not going to take the same orientation, okay? It's not going to be in the same position, okay? So here's why. What do we know from angle 0 to angle pi over 2? This right here, this from here to here is quadrant 1, right? Quadrant 1, this angle from 0 to pi over 2 is quadrant 1. That's this one. Well, what do I know about my x's and my y's in this quadrant? Well, they're both positive. So when I do a ratio of x to y, any ratio in this quadrant, that deals with x's and y's, I'm going to come out with a ratio that's positive. That means from here to here, my ratio is positive. My outputs is my ratio, right? And I have a vertical asymptote here. This has to be above the x-axis. So for this one, my graph has to actually start on right here and go through this point, okay? So it's going to come along the vertical asymptote and then turn and go through pi over 2. Now, what's happening between pi over 2 and pi? Well, what's that describing? Pi over 2, the angle of pi over 2 to pi describes the second quadrant, right? This is quadrant 2. Well, what do I know about the ratio of y to x in this quadrant right here? Well, in this quadrant, my x's are negative and my y's are positive. So anytime I do a ratio of those, I'm going to get a negative ratio. That means the graph for cotangent has to be below the x-axis between pi over 2 and pi. At pi, we have a vertical asymptote, so it has to be coming down for this vertical asymptote right here. Okay, so it's going to come down like this. Okay, and then come along that vertical asymptote. Okay, so how about pi to 3 pi over 2? Well, what do I know about in this quadrant? This is quadrant 3. So from pi to 3 pi over 2, that's quadrant 3. What do I know about my x's and y's in that quadrant? Well, they're both negative. Well, if they're both negative, when you go to do the ratio, that's going to cause it to be positive, right? So that means from pi to 3 pi over 2, my graph must be above the x-axis. So my graph is going to have to, and it has to approach this vertical asymptote. So it's going to have to be above, and that's why that part of the graph looks like this. See how it's the same shape, but the orientation is slightly different, right? Okay, instead of increasing, this one's decreasing. Okay, tangent increases and cotangent decreases. Okay, so as you go left to right. Okay, 3 pi over 2 to 2 pi, that's this quadrant, right? That's quadrant 4. See, if you forget the graph, you can think your way through this. Okay, that's why I'm teaching it to you this way. Okay, in quadrant 4 right here, okay, I know my x's are positive and my y's are negative. So when I do the cotangent ratio, right, of x over y, right, I know that this is going to have to come out to be negative. That means this part of the graph has to be below. And that's why it's below, okay? And it has to end up on this vertical asymptote right down here. And we've gone from 0 all the way to 2 pi. So we've done one full rotation, right? And now you can kind of see, oh, I know what's going to happen. It just repeats, right? Yeah, so it's just going to repeat. So we're just going to draw this one in. Like, we don't have to do the thinking like I've just been going over with you, okay? You don't have to do that all the time. Once you've established 0 to 2 pi, you're just going to fill it in, okay? And so this side is going to look this, it's going to be the same orientation because it's repeating, right? It's going to look like this. This one's going to look the same. And this one's going to look the same. And again, it's the shape of the graph, right? It's the shape of these graphs. Okay. Normally I give you a graph test on these 6 graphs. Okay. It's really important that you can picture these. But it takes some time, but you need to be able to picture these and kind of do them in your head. And this analysis of, okay, that puts me in the first quadrant and the ratio has to be positive. And I know at angle 0, there has to be a vertical asymptote, and all of that putting together is what we need to be able to do for calculus, okay? Is because it has to do with like approaching things, okay? And you'll see when you take calculus, like you're gonna, if you don't take the time to learn this, okay, it's gonna be really hard. You're gonna have to learn it then, okay? And it's gonna be really, really, you're gonna have to learn this on top of calculus, which is really hard, okay? All right, so that's why I'm spending the time with you guys on this, okay? All right, so let's go and do the next two, which is secant and cosecant, okay? We'll do that next. So once again, the radius is 1, and I should say this. We're gonna graph y equals cosecant x, which remember is the reciprocal of sine. So this is 1 over sine of x. Okay, so sine is y over r, right? Sine is y over r. So cosecant would have to be the reciprocal of that. So that's going to be r over y. We're going to use radius over the y coordinate, okay? And that's going to cause some points to be undefined, okay? Okay, so right here, okay, we know that this point, if we have a radius of 1, that point right there is angle 0, and we'd have 1, 0. This point right here would be 0, 1. This point right here would be 0. Oh, well, not 0. Whoops. Whoa, whoa, whoa. Negative 1, 0, right? And then this point right here would be 0, comma, negative 1. And then we're back up here to 2 pi, right? And this is angle 0, angle pi over 2, angle 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is really just 2 pi, right? Okay, so we're going to go from 0 to 2 pi, and we're going to figure out what the coordinates are, okay? So at angle 0, okay, cosecant is reciprocal of sine, okay? So at angle 0, sine is y over r, so this one's going to be r over y. So this is going to be 1 over 0. Well, what do we know about 1 over 0? That's undefined, right? So we have 0, comma, undefined. Well, what does that mean when you have a number over 0? That means you're going to have a vertical asymptote on the graph, right? Okay, so for cosecant, we're automatically going to have a vertical asymptote at angle 0. So we'll draw that in. Okay, and then we'll go to angle pi over 2. Okay, at angle pi over 2, remember sine is y over r, so this one's going to be r over y, so that'd be 1 over 1, which is 1. So at angle pi over 2, I know I'm right here at 1 because the scaling's by 1 because this one's 2. Okay, keep going around at pi. Okay, so angle pi. At angle pi, remember sine is y over r, so this one's going to be r over y. So 1 over 0. 1 over 0. What's 1 over 0? Undefined. So at angle pi, the output for this function is undefined, right? Which tells you you have a vertical asymptote at angle pi when you graph the trig functions, okay? You have a vertical asymptote for this function, for this particular function, okay? How about 3 pi over 2? At 3 pi over 2. See, all you really need is this little diagram right here, right? I mean, you can create this in your head. You might, some of you might already be doing it, okay? 3 pi over 2, okay, sine is y over r, so this one's going to be r over y, 1 over negative 1. So at 3 pi over 2, it's going to be negative 1. So 3 pi over 2, negative 1, that's this point right there, okay? And then 2 pi, right? We're back to 2 pi. Back where we started, right? And it's y over r, is sine, right? Sine is y over r. So cosecant is r over y. That'd be 1 over 0, which is undefined. So at angle 2 pi, the cosecant ratio is undefined. We can't get an answer to it, right? And that means we have a vertical asymptote. Okay, so we've gone one full rotation in the counterclockwise direction with a positive angle, right? And so I bet you can just use that to help periodically like know where to place everything, right? So where's the next vertical asymptote? It'd be at 3 pi, okay? So we'll plot vertical asymptote at 3 pi. And that's the last vertical asymptote on the right-hand side. How about the left-hand side of the graph? Well, there's going to be another one where? Well, there's going to be another one at negative pi. They're equally spaced. For right now, they're equally spaced, okay? And actually for this class, they're going to be equally spaced. But they don't have to be. We can do different things that causes them to be unequally spaced, but that doesn't really happen in this class anymore. So at negative 3 pi, right? So every pi, right, even in odd pi's, right, where you're going to have a vertical asymptote, okay? Well, what else is going to happen? Well, right here at 1, then negative 1. So at 5 pi over 2, what do you think is going to happen? Well, 5 pi over 2 would put us back to where pi over 2 is. So it's going to act the same way as pi over 2. So it's going to be at 1, okay? And you can see how it's alternating up, down, right? So then down here, it's going to be at negative 1. Then the next one's going to be at 1. The next one's going to be at negative 1, and so on, right? Okay, now what the heck does this graph look like though, right? What does this graph look like, okay? So what do we know, okay? From 0, we're going to kind of go through and do the same thing. From 0 to pi over 2, this is quadrant 1. And from pi over 2 to pi, that's quadrant 2. And from pi to 3 pi over 2, this is quadrant 3. And from 3 pi over 2 to 2 pi, that's quadrant 4. Well, what do I know about just the sine ratio, or because this one's going to be the reciprocal of sine ratio, so the sines are going to be the same as sine, S-I-N, right? The sine of your cosecant ratio and the sine of your sine ratio will be the same sign, S-I-G-N, okay? Whether it's positive or negative, okay? So what do we know? The ratio of r over y, right? In this quadrant, it's going to be positive. Why? R is always positive. It's 1, okay? Your y is positive here. Your y is positive over here. That means your ratio anywhere between 0 and pi, your ratio has to be positive. The entire graph of this from 0 to pi has to be above the x-axis. So how do you graph it if it's above the x-axis and you have these vertical asymptotes? Well, that means you just are going to end up here, and you also have to end up here. Well, to get from here to here, you're going to have to come down and turn around, right? And you turn around right there. That's the turnaround point right here, okay? So it's going to be kind of U-shaped, all right? So it's going to look something like this. Up U and down U, okay? That's how I usually tell people. Okay, how about pi to 2 pi, okay? How about this one, right? Well, what do I know about my y's from pi all the way to 2 pi? Well, they're all going to be negative, right? All my y's in these two quadrants are going to be negative. In quadrant 3 and quadrant 4, my y's are negative. That means when I go to do the ratio of r over y, my ratios are going to all be negative. This part of the graph has to be entirely below the x-axis, but it has to still have these vertical asymptote behaviors, right? So this one's going to end right here, and this one's going to be right here, and that's the turnaround point. And so these alternate between up U's and down U's, okay? So that's all there is to this, is that these are just going to start alternate, because from 2 pi to 3 pi, right, is the same behavior as 0 to pi, okay? Okay. And then over here from negative pi to 0, it's going to be a down U. But I don't want you to memorize it. Oh, it's just going to be a down U. No, why? Because from 0 to negative pi, what do I know about my y's down here? They're all going to be negative, right? So when I do the ratio, it's going to be negative, which means the graph of this has to be below. Keep going from negative pi to negative 2 pi, right? That's going in the clockwise direction, right? That's going to put me in these two quadrants. Well, my ratio of r to y has to be positive because my y's are all positive in these two quadrants. So that's why this part of the graph has to be above. I said I wasn't going to do the analysis through all this, and yet I am, huh? So it's going to look like this, right? But this is why they're going to alternate, right? All the ratios in this between negative 3 pi and negative 2 pi, they all have to be negative, right? Because in those two quadrants, if you rotate into them, you have to be negative, right? Their y's are negative, okay? And that's how cosecant looks like, okay? And I really want to, okay, for homework tonight, I'm having you graph these again, okay? But I want you to go through the analysis and do it yourself, okay? That's what I want you to do, okay? Do this analysis yourself, okay? I'm kind of walking you through it and how to think through it, okay? But I want you to do that, okay? All right, so let's go to the next one, okay? Okay, so this is we're gonna graph the graph of y equals secant of x. And secant is the reciprocal of cosine. So 1 over cosine x. And cosine x is x over r. So the reciprocal of that would have to be r over x. So we're going to look at our radius, and our x coordinate. And once again, the radius is 1, right? Surprise, surprise. At angle 0, this would be 1, 0. At this point right here at pi over 2, it'd be 0, 1. Over here at rotation of angle pi, that would put you at negative 1, 0. 3 pi over 2 would put you at 0, negative 1. Okay? So what happens when I do angle 0, right? Angle 0, okay? So secant, I'm finding the secant, okay? So cosine is x over r. So this one's going to be r over x. So 1 over 1, that would be 1, right? So that puts me right here. Angle 0, the ratio would be 1, okay? How about pi over 2? Pi over 2 would put me right here, right? Cosine is x over r, so this is going to be r over x, so it'd be 1 over 0. Now, what's 1 over 0? That's undefined, right? So I'm just going to go right to saying undefined because we've done this enough, I think. What does that tell me? We have a vertical asymptote there, right? Because we have 1 over 0. Okay, so we have a vertical asymptote at pi over 2. Keep going. Angle pi, okay? Angle pi. At angle pi, the cosine is x over r, so this one's going to be r over x. So 1 over negative 1, right? So that'd be negative 1. So at angle pi, we're at negative 1, which would be right there. Keep going to 3 pi over 2. 3 pi over 2, r over x would be 1 over 0. That'd be undefined. See how we're starting to go a little bit faster? So at 3 pi over 2, I should be drawing a vertical asymptote. And I would love it if you could just do this in your head. Okay, and then 2 pi, we're back to where we started with, right? And r over x, that'd be 1 over 1, right? So at 2 pi, we're back to 1. Okay, so at 2 pi, we're back here. Okay, so now you look at this and go, okay, you've shown all the key features from 0 to 2 pi. Can you tell and place where the vertical isotopes are going to be? And they're going to be at all the pi over 2s, all the odd pi over 2s, okay? So at 5 pi over 2, we're going to have another one. That's it for the right-hand side. On the left-hand side, we'd have one at negative pi over 2. Now, I don't want you to memorize, oh, they're all the odd pi over 2s. It's not a memorized thing. It's an understanding of why it's that way. Because these are cyclical, they repeat. These are all called periodic functions because they periodically repeat. Okay. All right. How about these points? Okay. So this one's at 1, this one's at -1, this one's at 1, this next one would be at -1. Over here, this one is at 1, so the next one would have to be at -1. That one's at -1, so this one would have to be at 1. This one's at 1, so this next one would have to be at -1. Okay. Now, how about from 0? This right here, right, from angle 0 to angle pi over 2 is the first quadrant, right? And the first quadrant, what do I know about my ratio of r to x? Okay, it has to be positive, right? Because in this quadrant, your x's are positive, and r is always positive. So r is not going to determine the sign of it. It's going to be your x's that determine the sign of it. So this is going to have to go, and again, this is going to be a turnaround point. So it's going to look very similar to the last one. Okay, it's going to come up along the vertical isotope like this. Okay, from pi over 2 to 3 pi over 2 in these two quadrants, right? This is the second quadrant and this is the third quadrant, right? What do I know about my ratio? My ratio is going to be negative. Why? Because in these two quadrants, your x's are negative and you're going to do r over x has to be negative, right? So the entire, from negative pi over 2 to 3 pi over 2, the entire graph has to land below this x-axis. So it's going to come up along the vertical isotope, turn around at pi, and then come back down, okay? And so these are up U's and down U's also, right? So once you do a couple of them, you can get, okay? 3 pi over 2 to 2 pi, this region right here, okay? This region right here, I know my x's are positive. My r's are always positive. So when I do the ratio, it's going to be positive. So that's going to look like this, has to. Okay, now we've graphed everything from 0 to 2 pi, and now we're just going to repeat, right? So this side right here, 0 to negative pi over 2, that's this quadrant, right? That's the same as this one, right? This is just with a negative angle versus going all the way around to here. It's the same quadrant. This one right here and this one right here are the same quadrant. So then this has to come down like this. And then you can just do from 2 pi on, this has to have to be positive. So this side has to be above the x-axis. So it has to do this. And then up U's and down U's, right? So this one's going to be a down U. And this comes down a little bit because that's a turnaround point right there. And up U's and down U's, but not because you memorize it. You know why. And they're horizontal down here. These are like parabolas that are, they're horizontal right here and here and here and here, here. Okay, that's not very drawn very well, but right there should be. Okay. Okay, that's how you graph the 6 trig functions. Okay, now what does it all hinge on all of these 5 points, right? Now I didn't do a bunch of points, right? I just did the ones at that land on the x and y axis and go around 2 pi, right? So that's why we call it the 5-point method, because you're doing the first point right here at angle 0. So 1, 2, 3, 4, and then you finish up where you started, right? So that's the 5th point. Okay, so this is called the 5-point method for graphing trig functions. Okay, and it's really helpful to have this diagram memorized in your head so that you can retrieve it and you can graph any of these, okay? All right, we are going to be doing some transformations with these, okay, over the next few days, but I'm going to have you practice graphing these a lot, okay? Because you need to go through this analysis that we did today. You need to do it, okay? So today's homework, okay? I'm going to grab it for you, and I want to talk about it a little bit, okay? So here's the homework, okay, that I want you to do tonight. Now, it looks just like what we've been doing, right? But please do not just take what we did and just copy and transfer it over. That's pointless. You might as well not do it because you're not getting what I want you to do out of this, okay? I want you to go through the analysis of going around the unit circle, right, with a radius of 1 and coming up with points. You don't have to draw the diagram. If you can do them in your head, that's great, okay? But you know why the point for sine x is right here at the origin. Like, not that you haven't memorized, you know why it's there. And you know what, pi over 2, it's at 1, okay? So go through and know where the vertical asymptotes, where it hits 1 and where it hits -1 and the zeros and all of that, okay? And you're going to be better off if you do that, okay? All right. And then the analysis, okay, it has to be above the x-axis because in that quadrant the ratio is positive, or it's below the x-axis because the ratio in that quadrant is negative, okay? And going through that, okay? So we're going to do this for the next 3 days. If you look at your the calendar, you're going to see graphing trig practice, okay? Because we gotta have a mental picture of what these graphs look like, especially the ones with vertical asymptotes, okay? All right, for calculus, you got to be able to visualize these, okay? And know where the vertical asymptotes are for, like, like tangent and cotangent and those, okay? So let me give the assignment sheet out and I'll show it to you, okay? So here's the assignment sheet for today, and then it's worksheet GTF1, okay? And it's the 5-point method, okay? We're going to start modeling with some stuff with these trig functions, okay? And then notice here, graphing trig functions 1, right? Graphing trig functions 2. That's where we're going to get the practice of graphing these, okay? So all your homework tonight is to graph these 6 trig functions. Go through the analysis yourself. I would wait a little bit after you do the notes, okay? Wait a little bit to see if you can remember how to do it, okay? All right. I may not do solutions on these because the notes have the solutions on them, okay? And all you'd have to do is look at the notes. But I'm going to decide that in just a few minutes here, okay? All right, so you guys take care. Have a great day. Thanks for joining me. All right, take care. Bye.